So here's another different example. We want to calculate another surface integral where the surface is now the portion of this curve, which is a paraboloid. If you can't remember that it's a paraboloid, think of it being like if r squared is x squared plus z squared, if it were polar in a strange coordinate sense, then y equals 3r squared. So just equaling something times r would be a cone. Equaling r squared should be like a rotated parabola. Cone is a rotated line. Okay, so that can help you figure out that that's a paraboloid if you don't remember, and then cut off by this plane. Okay, so we probably do need a picture of this one. What does that look like? X, Y, Z. Okay, so I'm going, all my y values are non-negative. So at the origin, at x and z equals 0, y is 0. And then y is increasing, and it's increasing in a paraboloid sense. The 3 just makes it a skinnier paraboloid. And then at some point we have y equals 6, so we're cut off at this plane. For convenience, we'll just say it's there. So we are looking for, over that surface, we're integrating this function 40y. Okay, so we could start off the same way as we did last time, right? Instead of z equals, it's a y equals. That shouldn't stop us. So maybe I'll parameterize it in x and z this time. And so x will just be x, and z will just be z. And then y is just going to be 3x squared plus 3z squared. Why can't I do that? Okay, then r sub x, I do a partial derivative with respect to x, that's 1, 6x, 0, and partial derivative with respect to z, that's 0, 6z, 1. Okay, so then I can calculate the cross product, which is the determinant of this matrix, 1, 6x, 0, 0, 6z, 1. That is 6x, comma, -1, comma, 6z. And so then the magnitude of the cross product, cross rz, is the root of 36x squared plus, I'm going to change the order to make this look a little better, 36z squared plus 1. Okay, and then I need to look back at my original integral. It was 40y, and y was this thing. So I'm going to get 120x squared plus 120 z squared. So I'm calculating 120x squared plus z squared times the root of 36x squared plus 36z squared plus 1. I'm going to need a dx dz in some format. Okay, what region am I working over? Well, I'm parameterized in x and z, so I need to look at the shadow of this surface in the xz plane, and it's a circle of radius 6. It's that circle translated over to the xz plane. Okay, so this is going to be kind of ugly, right? We're going to have like, oh no, not a circle of radius 6. What radius is that circle? Well, y is 3 times x squared plus z squared. So that means x squared plus z squared actually equals 2 when y equals 6. Okay, so it's a circle of radius root 2. Alright, x squared plus z squared equals 2, and then everything inside it, so like less than or equals 2, I guess, is the region. Okay, that's kind of annoying, because then my bounds are like negative root 2 to positive root 2, and then like negative 2 minus root of 2 minus z squared to the root of 2 minus z squared. Also, these I'm not sure how to do these integrals. I have an x squared out here and an x squared in here. This screams convert to polar, which I could do. Or I could go back and reparameterize this. or maybe have been smarter from the beginning. So with experience, you'll know from the beginning that maybe this isn't the best parameterization because of how it's going to turn out. So maybe instead we'll parameterize it like this. R, I already have a little r, so I like to make it different. So even though it's going to look polar, I'm going to make a big R. And then it's a little bit weird because the polar will be in the x and the z. So I'm going to put r cosine theta here, r sine theta here. And then my y is 3 times x squared plus y squared, so it's going to be 3r squared. That's a different parameterization of this. And now maybe if I work this way, my life will be easier. Okay, so taking partial derivatives again, this is cosine theta, comma 6r, comma sine theta, and then take partial derivative with respect to theta, that's negative r sine theta, comma 0, comma r cosine theta, and then I need to find the cross product again, r sub r cross r sub theta, I, j, k, cosine theta, 6r sine theta, negative r sine theta, 0 r cosine theta. Let's see, that is going to be 6r squared cosine theta, comma, and this is r cosine squared theta plus r sine squared theta, so it's r, and then j comes, remember, with this, this alternating minus sign. So I am going to end up with a minus r here. And then in the k coordinate, I have 0 minus negative, so positive 6r squared sine theta. Okay, maybe I'll go down here for more space. So then the magnitude of r sub r cross r sub theta is going to be the root of, this is actually going to be 36r to the 4th, sine squared theta plus cosine squared theta is 1, plus, and then it'll be that, so r squared. A little weird. And then we're going to keep, so the region, again, it was a circle of radius root 2, so r is going to be from 0 to root 2, and then theta is going to be from 0 to 2 pi. So because we're keeping r non-negative, then we can pull an r squared out of the root and get an r, no problem. So this is 36r squared plus 1 now. That's a little bit nicer to look at. Okay, we're still taking the integral of 40y, and now y is 3r squared. So we're going to get 120 r squared. And then multiplying by this, r times root 36r squared plus 1 dr d theta. Theta goes from 0 to 2 pi. R goes from 0 to root 2. And notice that even though it's polarish, we don't need an r dr d theta. In fact, if we converted this other integral that we had before to polar, the r, so this x squared plus z squared gets converted to r squared. Here, the root gets converted to the root, that's fine. And actually, the r is already here. So over here, converting to polar, you would need an r dr d theta. If you just parameterize it directly with polar, you don't. Okay. And then this integral is actually a little bit funny. You can actually do this with a u sub, but it's a little bit weird. So u is going to be the thing you can't do anything about, which is under the root. So that, and then du is 72r dr. Let's see what we have. 24 goes into 120 and also into 72. So I'm going to write 24r dr is 1/3 du. That's what I'm going to sub in. And so then I can grab the r dr, and then I still am left with an r squared. So I need to go up here and solve for r squared. So that's u minus 1 over 36. Okay, so what that gives me, 0 to 2 pi, this is r going from 0 to root 2. I'm going to have u's in a second. Okay, so 24 goes into 125 times, so I leave a 5 here. Let's see, I acquire a 1/3. The r squared gets subbed out with u minus 1 over 36. The 24r dr was all together, and then I have a root u here, du. Take a minute, make sure I did that right. Okay, but now it's all fine, because that's a power of u, and those are powers there. So maybe I'll take out, I don't know, 5 over 108 out here, 0 to 2 pi, r going from 0 to root 2, and then what I'm left with is u to the 3/2 minus u to the 1/2 if I expand that. And then I can use power rule and integrate. So that'll be fine. Okay, and then maybe I won't do the rest of this integration. It comes out to some ugly number. I think if you work it out as decimal, it's in the 5,000s. All right, so there's another different example of a surface integral.